Hello, Prosperivarians. The best school has come to stay in the city of Calabar. It is called Beryl International School. Take advantage of this opportunity now.
Tell me the best school, Beryl is the best. Tell me the best school.
Hello, welcome to chemistry class. Yes, I know you are enjoying the lockdown, but now we have come to help you on enjoying better, in the sense that you're going to be studying very hard. Now today we are looking at the topic known as acid, base and salt. Now in this topic, I think it's going to last for 3 or 4 weeks thereabout. Okay. For this topic we'll look at briefly definition, of acids. We'll look at classification of acids. We'll look at basicity. Basicity of acids. We'll look at properties of acids. We'll look at preparation of acids. I think this should be enough for today. Okay, now what is an acid? If you are asked what's an acid, what will you say? An acid is defined as a substance which, when dissolved in water, will produce hydrogen ion, or you call it ozonium ion or hydrozonium ion, as the only positively charged ions. So in other words, we'll say an acid is a substance which, when dissolved in water, will produce hydrogen ions or hydrozonium ions as the only positively charged ions. Do you get that? So an acid is a substance which, when dissolved in water, will produce hydrogen ions or hydrozonium. If you don't call it hydrozonium, you can also call it ozonium. Hydrozonium ions as the only positively charged ions. In other words, any substance that produces positively charged hydrogen ion or ozonium ion is tend to be an acid. Take for instance, if you dissolve HCl in water, that's H2O. This is a liquid, this is an aqueous solution. It will produce H3O plus, isn't it? In aqueous state, plus Cl minus in aqueous state. That's an acid. Or better still, if this acid ionizes in water, if you have HCl in aqueous state, if it ionizes in water, it will produce H plus Cl minus. This is in aqueous solution. This is also in aqueous solution. So that could be termed an acid for the fact that it produces hydrogen ion or ozonium ion in solution. Okay? The next thing is that we will look at is classification of acids. How do we classify acids? Acids are classified into two classes or groups. Now, acid can be classified as one. Either you call it organic acids, and then two inorganic acids. You see it? We have organic acids and inorganic acids. These are classes of acids. So it could either be organic acids or inorganic acids. Now, what organic acid was inorganic acid? Organic acid are those acids that are called naturally in plants and animals. I take that again. Organic acids are those acids that occur naturally in plants and animals. Whereas inorganic acids are acids that are prepared in a laboratory. They are synthesized in a laboratory. They are gotten from mineral deposits. Is that clear? So let's take examples of organic acid and their source. So you have organic acids, and then source. The first type of organic acid is called metanoic acid. Metanoic acid. And metanoic acid is from ants. Are you surprised? Metanoic acid is gotten from plants. Metanoic acid is gotten from ants. The next, which is ethanoic acid. These are organic acid, ethanoic acid. Ethanoic acid is gotten from vinegar. Ethanoic acid is gotten from vinegar. And then another acid that may interest you is lactic acid. Lactic acid. Lactic acid is from milk. And then we have ascorbic acid. Right beside the vitamin C. Those of you who like taking vitamin C a lot. Ascorbic acid is gotten from oranges. It's gotten from oranges, and so on and so forth. You have citrus acid from citrus fruits. You have fatty acid. You have from fat and oil. You have amino acid from protein, and so on and so forth. Those are other examples of organic acid. Let's also look at the inorganic acid. inorganic acid. And their source or sources, beg your pardon. Now, one. Examples of inorganic acid, just like the one you have there, hydrochloric acid. Hydrochloric acid is inorganic. Now, inorganic acid, I said, they are gotten from mineral deposits and they are prepared in the laboratory. They don't occur naturally, whereas organic acid occur naturally from plants and animals. Inorganic acid, one, we have hydrochloric acid. Hydrochloric acid is gotten from chlorine, as from chloride ions or chlorine. I told you source could be, let's put chlorine. Can get hydrochloric acid from chlorine. Another example of inorganic acid is hydrogen tetraoxo sulfate 6. Hydrogen tetraoxide 6. This is from sulfide ions. You can call these chloride ions or chlorides. Chlorine, chloride. This is from sulfur. From sulfur deposit, or you call it, let's say maybe chlorine deposit. And so forth. Then we will have the third type of acid, inorganic acid, could be hydrogen triazoxo nitrate. Hydrogen triazoxo nitrate 5 is gotten from nitrogen deposit, and so on and so forth. Okay, now we will go back to the next, which is basicity of acids. Basicity of acids. Okay, I take this off. Basicity of acids. Basicity. This is defined as, okay, let's say, basicity is the numbers of replaceable hydrogen ions in a molecule of acid. So, the number of replaceable hydrogen ions in one molecule of an acid defines the basicity of that acid. The number of replaceable hydrogen ions in one molecule of the acid defines the basicity of the acid. Examples. Now, let's put down this way, basicity made a mistake. You have acids and you have basicity. Acids and their basicity. And your basicity. Okay? The first one, let's pick HCl. HCl. Now, if it dissolves in water, this is a strong acid, so I'll use a single arrow for it. It will form H plus Cl minus. I should use this earlier. Now, if it dissolves in solution, you will have hydrogen ion and the chloride ion. Now, the basicity of that acid, because we said it is the numbers of replaceable hydrogen ions in one molecule of the acid, it becomes, you have 1. The basicity of hydrogen chloride is 1. And because it is 1, if you are to call it, it becomes monobasic acid. Monobasic acid. If we have H2SO4, of course, it's also a strong acid. When it dissolves in water, it dissociates to form 2H plus SO4 2 minus. Now, the basicity of such an acid is 2, because the number of replaceable hydrogen ion of this acid is 2, and such an acid is called dibasic acid. It's called dibasic acid. The third type or example I'm going to give now is anorganic acid CH3COOH. This is an organic acid. CH3COOH. Okay? So, this acid, you may be wondering, how many replaceable hydrogen ions will we have? We find that it has 4 hydrogen in its molecule. Well, it's just 1. How? Which is this? This is another compound entirely, and it's formed. Okay. So, if we dissociate in water, for the fact that it's a weak acid, I have to use double arrow. So, H plus CH3COO minus. Now, please don't forget, all of these are in aqueous solution. Please pardon me. They are in aqueous state. And so on and so forth. In aqueous state. So the basicity of that acid is 1. And that is what? On the board, monobasic acid. And then the one I would like to show you is also part of this, or you see it later. It's also acid are not just dibasic or monobasic. We can have tribasic, such as we have H3PO4. Such an acid, if you dissolve the water, it will be 3 hydrogen. So this is tribasic, and so on and so forth. Now we will look at the properties of acids. Properties of acid. Now, how can you identify an acid? Properties, we'll look at physical properties of an acid first before the chemical properties. Now, you have physical properties of acids. Physical properties of acid. Okay, 1. Acids have sour taste. They have sour taste. Like the taste of unripe fruits. Have you tried to attempt to taste unripe fruit before? You can try it after this class. An unripe fruit tastes like an acid, is sour taste. Another property of acid is that acid turns blue litmus paper red. Acid turns blue litmus paper red. Acid turns blue litmus paper red. Isn't it? And then the third property of an acid is that they are corrosive. In other words, they can burn the skin. So strong concentrated or concentratedly strong acids burn the skin as they are corrosive. Right? Concentrated strong acids burn. Let's use burn the skin. Let's say are corrosive. That means they burn the skin. You get that? I said concentrated strong acids are corrosive. Concentrated strong acids are corrosive. That is, they burn the skin. Okay, chemical properties of acid. Chemical properties of acids. 1. The first chemical property of an acid we'll look at is what I call neutralization reaction. It's a chemical property of an acid. Neutralization reaction is a chemical property of an acid. And then we also know that acid reacts with metals. They react with metals. So acid also reacts with carbonate 4 salts. They react with carbonate 4 salts, they react with metals, and then they react with base. I told you earlier that neutralization reaction is one property of acid, so an acid does not undergo neutralization reaction without a reaction with a base. So reaction with base, reaction with metals, reaction with carbonate 4 salt. Let's pick one. Reaction with metals. Reaction with metals. Acid reacts with metals to produce the salts of those metals. Let's take, for instance, you have zinc is a metal. If zinc reacts with an acid, let's say H2SO4, SF plus H2SO4. This is in aqueous state. It will produce a salt, a corresponding salt of such a metal as ZnSO4, ZnSO4 plus the evolution of hydrogen gas. Hydrogen gas. You see it? So an acid reacts with metals to produce the corresponding salt of such a metal and hydrogen gas. Another reaction I said is with a base, that's neutralization reaction. You can't discuss an acid or a base without mentioning neutralization reaction. Neutralization reaction. So if an acid will react with, let's say, H, okay, let me put it is with 2. Reaction, please mind my right. Reaction with a base, we'll call it neutralization reaction. Neutralization. So an acid reacts with a base to form salt and water only. An acid reacts with a base to form salt and water only. And that is HCl is an acid in its aqueous state plus NaOH, also in aqueous state, to produce NaCl plus H2O. This is in liquid. This is in aqueous. Is that clear? Now this is the normal salt you use in the kitchen or at home in preparing meals or food. Okay? So this is a typical neutralization reaction. An acid reacts with base to form salt and water. That's neutralization reaction. Tell me, reaction with triazocarbonate. React triazocarbonate. A typical example of triazocarbonate is sodium triazocarbonate. Sodium triazocarbonate, and that is Na2CO3. Now, if an acid, either hydrochloric acid or sulfuric acid, react with this, it will produce the corresponding salt of that metal in there, will produce also water, and then to produce carbon 4 oxide. So if this reacts with, let's say, HCl, it will produce, look at the reaction there, NaCl plus H2O plus CO2 gas. This is a liquid, it is in aqueous state. So when triazocarbonate 4 compounds react with acid, it produces corresponding salt of the acid, of the metal, and to produce water, and then it will also produce carbon 4 oxides. Let's hurry now quickly to the preparation of acids. Preparation of acid. We have looked at definition of acid, classification of acid, resistivity of acid. Now we'll look at preparation of acid. How do you prepare an acid? Briefly, we'll look at just 2 or 3 methods on how we can prepare an acid. 2 methods or 3 methods on how we can prepare an acid. Okay? Preparation of acids. How do you prepare an acid? An acid, first of all, can be prepared by the simplest method now in preparing acid is what we call direct combination of the constituent elements. Direct combination of the constituent elements. One, acids are prepared by direct combination of the constituent elements. Constituent elements. As the element it contains, take for instance, hydrogen gas can directly combine with chlorine gas to form hydrogen chloride gas. You see it? Direct combination of the elements. Another method is the reaction by reacting an acid anhydride. This is the acid anhydride with water. Reacting acid anhydrides with water is another method of preparing acid. Now, in this method, you will want to understand what is anhydride. Acid anhydrides are oxides of non-metals in which, when dissolved in water, will produce an acid. Acid anhydrides are oxides of non-metal in which, when dissolved in water,